Hello, my name is Mr. Werrick. I'm here to talk to you today about lesson 10.8, the last lesson from chapter 10. This will be the last thing we talk about in the chapter about circles. So what we're talking about today is the equation of a circle. This is something that you may use again in Algebra 2. You'll definitely use again if you go past Algebra 2 when you get into pre-cal, calculus, especially the parts that are dealing with trigonometry. You'll definitely be dealing with circles, equations of circles, all that kind of stuff. So you need to make sure that you understand this, you tuck this away in your memory, you'll be able to refer to it later on. So the standard form of the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. Now when you start to get into conic sections near the end of Algebra 2, or when you address those conic sections in pre-cal or cal, you will also learn about ellipses, which will have a very similar standard form to this, and hyperbolas, which will again have a very, very similar standard form to this. So if you can remember this standard form for circles, it's going to help you out a lot in the future. And how this works is this h and k are, in order x and y, the center of the circle. H refers to a horizontal shift, so H for horizontal, and then K for some reason stands for a vertical shift. Okay, you're used to a B, y equals mx plus b, but that can be again represented with an H and K. If you ask me about it during class, I'll refer to it. If you prefer not to think about it yet, we can skip over that part. It's not that big a deal. The R out here at the end is the radius. So basically what's going on is if you see this squared, this squared, this squared, we're dealing with a whole bunch of right triangles in all directions. And the distance, this radius, is always the same. So it's basically all of the different myriad ways that we can square two numbers and get them to have a distance of, say, 5 or 6 or 7 or whatever it is, by making a right triangle. So if we think about what the definition of something is, that all the points on it are equidistant from a center point, that is a circle. Okay, you can draw it with a compass, you can tell everything is the same distance from that center point that you drew with the compass, so that's what we're dealing with here. Kind of a distance formula, Pythagorean theorem kind of deal where it always comes up to the same thing. So our example here is we have a center at 3, 2, and this is what they'll give you. They'll give you a center. They'll say the radius is this, and they'll ask you to write it out. So it'll be x minus 3 squared plus y minus 2 squared is equal to 7 squared or 49. Either one would be an acceptable answer in that case. If you leave it as 7, it's easier to see what the radius was, but I'm not going to be particularly picky about how you express that last one. I'm going to be looking for, are these correct? Are the signs in front of them correct? Now, because this is minus, if you come up with negatives like -4, -5 for your center and still a radius of 7, that's going to be x plus 4. Minus -4 is too redundant. So we have x plus 4 squared plus y plus 5 squared is equal to, again, 7 squared or 49. Either way you want to express that. Sometimes they will give you the center and they'll give you another point. They'll tell you to use the distance formula. You can use the distance formula or the Pythagorean theorem. Distance formula is x2 minus x1 squared plus y2 minus y1 squared, and then the square root of that. I just like to count, so I use the Pythagorean theorem a lot. From this center at -2 to my point at -6, that's -2, -3, -4, -5, -6, that's 4. And then from 4 to 7 is 3. 4 squared plus 3 squared is equal to 25. So the radius, this is what I'm looking for here, is 5. Knowing that, I can write my equation as x plus 2 squared plus y minus 4 squared is equal to, again, 25 or 5 squared, either way. There is a section in here. It doesn't necessarily need to go into your notes, but it does talk about the intersections and finding intersections with a circle. You can graph circles with our calculators. It's going to be a little more difficult if you have a TI-83, TI-84, but if you have the Inspire like we have, there's a form to put it into. If you'll remind me on Monday, or not Monday, if you'll remind me on, no, this is Monday. If you'll remind me when we come to class for this lesson, I'll demonstrate how to enter this on the calculator, and it actually uses the standard form of a circle, and you kind of fill in the blanks there. So if you fill those in, you should be able to tell pretty easily where those are going to intersect. Remember, if you're intersecting with a circle though, a line intersecting with a circle intersecting with a circle, usually there's going to be two intersections the way they set those up. Now, if you get to a parabola, you can have 1, 2, 3, or 4 different intersections. They're probably not going to push you that far at this point in the book when they've just kind of introduced this. So what you'll probably mostly see is 2 intersections, but don't forget about those 2 intersections. Anytime you have a squared in here, you have to remember there's a positive way to get there and a negative way to get there. If we're going to get to 25 and we just have this x squared, it can be positive 5, it could be negative 5. So there's a couple of different numbers that you can put in there that are going to make that work. Okay? Hopefully that has got you on the right path for this one. If there's something that you don't understand, something you need me to go over more in detail, make sure to come in tutorials, raise your hand during class, ask those questions, and we'll see you then.